How many DFAs are possible with two states x and y where x is initial state over alphabet AB and that accept empty language. So in last lecture we have seen also, and it is given in my playlist. You can see from there also. So there can be how many possibilities with this zero states final. When zero states final means x or y both are not final, then how many possibilities are possible? 16. When start is x as it is given and final is y, then 16 possibilities are there. When start is x and final is also x, then 16 possibility may be possible, and both states x and y are final, so there can be 16 possibilities. Zero states final, then 16 possibilities. Start x and final y, then 16 possibilities. Start is also x, final is also y, there can be 16 possibilities. When both x and y are final, then 16 possibilities. So as we have two states x and y in which x is initial state over alphabet AB that accept empty language, we need to find out that accept empty language. So as when zero states final, so 16 possibilities are there. Because zero states are final, so obviously it will accept empty language. This is the first case in which it will accept empty language because there is no final state. So when there is no final state, then definitely it will accept empty language. When start x and final y, the second case, the start x and final y, then suppose if we have start x, y final, but the direction is like that, then definitely it will not accept anything, or we can say it will accept empty language because of the direction. So that can be the possibility. And what else? Like this, that can be the possibility that because of the direction it will accept empty language. And AB, y is a final state, because of the direction it will accept empty language. And this is also the case. So these four cases are possible when x is initial state and y is final state. Four cases are possible where it will accept empty language. And suppose if we do any change, because here we can see x is constant and y is changing. So if we suppose if we do any change in x, if we do any change in x, suppose if we do transition of A is on the A and transition of B like this, this will be the A, because transition of B is on the Y as a loop, and from there to here it will go A, and transition of A on X and transition of B on Y. So if we changing the direction, then it will accept something. It will not be the empty language because it is going from this direction to this direction. That is correct from starting to final state. So it will accept anything. So it will not come under this case where it will accept empty language. So these are the only four cases where it will accept empty language. If we change anything, then it will not accept empty language. So How many DFAs are possible? With 0 final state we have 16 possibilities, so 16 DFAs are possible, and start with X and final with Y. With the second condition we have these 4 cases in which we have DFA that accept empty language. Now move to the next, when starting state is X and final state is also X. Then what will be the possibility when start is X? In the third case, when start is X and final is also X, then definitely it will accept epsilon. And definitely it will accept epsilon. It is not empty language. So this case is not possible. And the fourth condition, when X and Y both are final, then definitely it will accept everything. In the fourth case it will accept everything, so it cannot accept empty language, which is our condition, that accept empty language. So this case is not possible. So how many DFAs are possible? Only the first case, when 0 final state is there, then when 16 DFAs are possible, and in the second case when start is X and final is Y, only 4 cases are possible. So how many DFAs are possible? 16 plus 4, that is 20 DFAs are possible with two states X and Y, where X is initial state, over alphabet AB, and that accept empty language. So there are only 20 DFAs are possible. Now move to the next. As we know that L union L complement, we have everything alphabet star, and L intersection L dash we have 5. There is nothing remaining, there is nothing left when we do intersection of this, and when we do union then we will have alphabet star. Suppose we have in DFA, or we can say in finite automata, in DFA, deterministic finite automata, L union L complement will be equals to alphabet star, and L intersection L complement will be 5. Suppose we have this DFA with S1 as initial and final both, and S2 state we have, this is a transition we have. Now we are going to change, suppose we have this DFA, and now we are going to change final to non-final. We are changing final to non-final. So what will be the, as we have S1 as a final state, so S1 as initial state, and the transition of B is remaining there, and S2 which was not final will become final, and from S1 to S2 A transition, S2 to S1 A transition, and S2 as B transition. So here we change final to non-final. All things are same. On S1 there is a loop of B, and S1 to S2 A, S2 to S1 A, and the loop of B on S2. But only thing is change final to non-final. So S1 will be remain as initial state, and S2 will be as a final state. So here ABA will be accepted or rejected. In this, ABA will be accepted or rejected. Obviously ABA will be accepted, because S1 as an initial and final both state. So A will be accepted because it is coming back to the final state. So it will be accepted. And BAB will be accepted or not? BAB will not be accepted because it is not coming to the final state. BAB will be rejected. BAB. It is rejected because it is not coming to the final state. So it will be the So it will be rejected. It will be rejected. And because here what we did conversion final to non-final, we did conversion. So we see the same strings are accepted here or not. ABA, as we have taken here ABA, so we are taking here ABA. So ABA will be accepted or not? ABA, no, it will not accept ABA because it is going to the non-final state, so it will be rejected. And what about BAB? The same string BAB. BAB will be accepted. BAB will be accepted. BA will be accepted. So here we can clearly see, because this is the complement conversion, because here we change final to non-final. We have this DFA here and we change it into the non-final state, so conversion. So we can say that the complement, we have done complement here, we convert final to non-final. So whatever strings is accepted here, it will be rejected here, and whatever strings are rejected here, that will be accepted here. So this is, we can say, the complement. We can say that the complement. So whatever accepted here, it will be rejected, and whatever rejected here will be accepted. So now, so this is the working of DFA. Now if we take NFA, for the same thing, S1 initial final state AB, because this is S2 make a loop of B, because this is NFA, so AB is also possible and A is also possible. Here we can see only B loop is there, rest things are same, but here we can take AB because this is NFA. Now we are talking about the NFA. So rest things are same, and if we take the complement of it, so obviously we just change the final to non-final state. Complement it, so S1 will be S2 AB A, and this will be the final state B. The final state B. Rest things are same. So here A will be accepted. A, yes, A will be accepted, initial state, final state, and here A will be accepted because it is reaching to the final state A. So we can say in NFA, complement string may be accepted or may not be accepted. So in NFA we can say complemented string may be accepted, may or may not be accepted. So what we can conclude from this? We can conclude from this, in DFA we will always in DFA we will always get complementation in DFA we will always get complementation, but in NFA complementation may not be possible or maybe possible. DFA will always get complementation, but in NFA, complementation may be possible or may not be possible. From here we can see clearly. In DFA, whatever we are accepted and rejected here, the same strings in the conversion or in complementation get rejected or accepted. Whatever is accepted here, it is rejected there. Whatever rejected there, it is accepted there. So complementation is always complementation is possible, get accepted. But in NFA, whatever is accepted here, same thing is also accepted here. So NFA we can say may be accepted or may not be accepted.